Today we're going through probability. So probability means the possibility of something happening. So there's a formula that we use for probability, which is quite generalized, but usually it's probability is equal to the favored number of outcomes divided by the total number of outcomes. So this means if I had 5 red counters in a bag of 10 counters, if I'm looking for the probability of taking out a red counter, it would be the number of red counters, which is 5, over the total counters, which is 5 over 10. So the probability of getting a red counter would be 1/2. Okay, so in probability there's many different types, but usually it's classed into 2 types. There's theoretical probability and experimental probability. So first we're going to look at theoretical. So we have this scenario where we have 10 chocolate eggs in total. So we have 5 cream eggs, we have 4 caramel eggs, and we have 1 white egg. So we have 5 plus 4 plus 1, 10 eggs in total. So if we want to work out the probability of getting a cream egg, we put the favored number of outcomes, 5, over the total number, 10. Now let's repeat this for the other ones. Put 4 over 10 and 1 over 10. Now, what would you do if you wanted to work out the chance of 2 events happening in succession? To do that, you can use multiple methods, but I'm going to go through the simplest one, which is a tree diagram. Okay, so I've drawn a tree diagram for cream egg, caramel egg, and white egg. So now we have to complete it. So the probability of pulling cream egg was 5 over 10. Probability of caramel egg was 4 over 10. Then we know that white was 1 over 10, but we could also work it out if this was unknown by adding these together and subtracting it from 1. Because in probability, a whole branch in the tree diagram always adds to 1. So this is 1 over 10, and then we complete. So if the egg is replaced after each time, it's an example of independent probability. So that's what we're going to go through first here. So it's 5 over 10, 4 over 10, and 1 over 10. Okay, so now we're going to try and work out the probability of, if I took a cream egg from a bag and I put it back in, what's the chances of me pulling another cream egg out? So to work this out in a tree diagram, we times along the branches. So we go to the first cream egg, we have 5 over 10. Then we go to the next branch that we want, so we want cream egg again. So we times 5 over 10 by 5 over 10. Now this is equal to 25 over 100, which is the same as 25%. And you can do this process for any other probability on this tree. Okay, so now we're going to go through experimental probability. So we have the theoretical probability of each of these happening. Now we're going to see if it matches up with the experimental. And we're going to do a little experiment with Adam. So could Adam please come to the stage? So what Adam has to do is he has to pull from this bag a cream egg an egg at random, and then we're going to tally how many times he pulls each one, and we're going to do this 10 times. So see the first one. Hold it up to the camera.
I have no idea what that is.
It's a cream egg.
It's a regular cream egg.
So you're going to tally it and you're going to put it back in.
It's a caramel.
Caramel. So we're going to put a tally there.
Should we just time lapse for all of these?
Yeah. Okay, so we conducted the experiment, and at the end we drew 6 cream eggs and we drew 4 caramel eggs and 0 white eggs. So I wanted to do this to show you that theoretical probability is not what is definitely going to happen. And that's why we have experimental, because if we followed the theory, then we should have gotten 5 cream eggs at the end of it, but we had 6. And the caramel was correct, but we didn't pull the white one at all for the whole 10 attempts. But using this, we can work out something called relative frequency, which is when you do a task, when you do an experimental probability, you divide this number by the total amount. So if we did this experiment 50 times, say we go up 25 cream eggs, we put it over 50, and that would be the relative frequency. And the more times you do a task, the more accurate it is going to be to the theoretical probability. Okay, so we've looked at examples where we've replaced the egg, and that's independent probability. Now we're going to look at dependent probability with this short example. The probability of getting a caramel egg the first time is 4 over 10, because there's 4 caramel eggs and there's 10 eggs in total. So say I wanted to work out the probability of picking out 2 caramel eggs without replacing the first one. So I would say that there's 4 in the first time, then we times it, so we've taken 1 out, so there's 1 less caramel egg, so 4 minus 1 is 3, and you don't put 10 because there's 1 less egg, there's 1 less caramel egg, so there's also 1 less total. So we put 9, times that together, get 12 with the 90. So this is the dependent probability. So guys, well done for getting to the end of the video again. I'd like to wish you all a happy Easter and good luck in your GCSEs. Please like and subscribe.